Okay, so good afternoon, everybody. And so my name is Guno Son, Associate Professor at Geomatics Engineering Programs in the Lasson School of Engineering, York University. It is my great pleasure to welcome you here today on behalf of the Geomatics Engineering Programs in York University. We're very much delighted to have you participate and share in our fifth GeoTalks virtual seminar series, and thanks for joining this meeting today. Geomatics Engineering Program at York University was founded 20 years ago. We will have a 20th birthday this year. So for almost 20 years in the past, many geomatics undergraduate, graduate students have been educated through our program, and who are now leaders in various fields of geomatics area as engineers, scientists, entrepreneurs, and educators. Our program has also primarily contributed to geomatics research communities and industries by conducting innovative research projects. So GeoTalks is a bi-weekly seminar series organized by Geomatics Engineering Program at York and also the Canadian Institute of Geomatics Toronto branch. And this series will host industry leaders and entrepreneurs in geomatics. This is a great opportunity to hear from industry leaders in geomatics who will introduce their cutting-edge geospatial technology through this seminar series. We're very much honored to have Dr. Nastaran Saberi with us today. So I'm going to briefly introduce her to the audience. Dr. Saberi is a co-founder and a CTO of GeoMate. And Dr. Saberi, who received her PhD in applied remote sensing from the University of Waterloo in 2019, and who is now co-founder and CTO of GeoMate, and location intelligence startup uses AI to analyze the near real-time safety and accessibility of cities. And she also holds the position of a researcher at the University of Waterloo at the moment, working as a co-modeler in the Global Water Future Program since 2019. Also at the University of Waterloo, Dr. Saberi contributed her knowledge about the geospatial domain as a lecturer and a mentor, and in the commercial sector, acts as a data growth coach for small to medium expertise, helping them to grow their geospatial data knowledge and machine vision, and AI and geodata pipeline integration. She is firmly committed to encouraging the use of the technology and AI for good, and adheres to socially responsible practice and in all her geo community activities. Despite a decade of research and development experience in geospatial science, Dr. Saberi remains excited to learn more about applied geoscience and the positive contribution it makes to society. In her talk title with leveraging geospatial intelligence and AI to improve the accessibility in cities. And Dr. Saberi will share her vision and experience at GeoMate, and prepare yourself to be challenged and excited and inspired. So that's brief introductions of Nastaran Saberi today as our guest speaker. So now, are you ready to give your talks?
Yeah, absolutely. Thank you so much.
So you can share. I stop my sharing.
Is it full screen now?
Yes.
Awesome. Thank you so much for the introduction. Welcome, everyone. I'm Nastaran Saberi, the co-founder and CTO at GeoMate, a location intelligence startup that uses AI to analyze the safety and accessibility of cities. I'm also a researcher at the University of Waterloo, and as Gonho mentioned, I'm committed to encouraging the use of tech and AI for good and adhere to socially responsible practices in all geo-community activities. So for all of you who are already in this field, in geospatial domain, I hope you find this presentation useful, and it may encourage you to reach out and connect. And for the ones who are thinking about joining this field, I hope this talk inspire you to investigate the ways in which geoscience and geomatics can do good in the world. So artificial intelligence, or AI, is transforming many things in our lives, and it's going to impact our businesses. It has been argued that AI is overrated, but today its power is not arguable. It has been shown how tasks can be automated and how big data can be transformed into information for decision makers. It is important to take this in mind that AI is going to impact many aspects of our life. And as we all know from Spider-Man, with great power comes great responsibility. There are a lot of discussions about how to do it responsibly, and there are many initiatives supported by or running by big tech companies around this domain. But I believe that there is still a lot more attention and investments needed to address environmental and social challenges using AI. There's more, effort need, and there's more need to have organizations to catalyze tech for social and environmental real world problems. And just one side note about my journey, I've been always excited about technology, science, and innovation. But the things that we can use in technology to impact people's lives has been really inspirational for me. And if you ask me what keeps you awake, the answer is take an AI for good, with a little bit of geo flavor for sure. And this helps me find a meaning in the busy life. But how tech companies can become more socially responsible when using AI? Solutions should end up serving civic role players, civic actors who are key decision makers that are, in this domain. The key decision makers that are making policies, and these policies should then incentivize and create programs that impact the lives of citizens globally. This might sound a little bit far from our role and responsibilities, but if we all do our best in becoming more socially and environmentally conscious while creating data backed insights and solutions, then we are making one step towards becoming more socially responsible. Why? Well, when we are using AI. The idea is to create tools and solutions to key decision makers and public sector, and not only serving the private sector. This helps decision makers make sound decisions. And to do so, we should connect NGOs, academics, industries more than before, and make sure that decision makings are based on robust research and academics. And let me give you one example. You might not be, you might not agree with me in this example. In the battle with COVID-19, we saw much more effective communications and coordinations between different sectors, at least countrywide or in most of the countries around the world. And I think this close relationship of industry, academia, and policy making showed how powerful we can respond in facing with crisis. But unfortunately, the crises are ongoing and we should be prepared, right? Small negative impacts can make disasters in a long span of time. The harnessing of emerging AI solutions can help us to secure major improvements in how we produce, store, and consume energy and water, as well as safely and sustainably convert and dispose of our waste. AI is allowing us to do more with what we have and to do with what we don't need in a much more sustainable manner. From self-driving vehicles making rubbish collections to smart grids, metering, and even smarter irrigation systems, AI is paving the way towards global sustainability. As an example, AI can help utilities and energy companies monitor the integrity of the pipelines, which allows predictive maintenance that prevent hazardous incidents. At city scale, AI is becoming a central element of urban planning. One example is where city planners can combine current projections with future trends of water availability or scarcity to optimize all investments in infrastructures. Another example is the smart tagging of waste that allows AI-powered system to take over the sorting process from the traditional mechanical ways. We can use technology to help people during crisis using AI. Predictions can prepare us for such disasters, right? We can give some heads up about disasters, saving lives and diminishing some of the damages. And it's obvious that faster and more efficient crisis response minimize the impact of disasters. There has been a lot of research on predicting natural hazards using geospatial data and analysis. And one example, which I have been involved in a research focused on flood prediction, for example, for many years, we can use hydrological models, SAR observations, and in situ measurements to model the flood and predict the occurrence of the flood. Another example is using seismic data. Machine learning models empowered by other geospatial data can analyze the magnitude and patterns of earthquakes and predict them. And benefits of predictions of occurrence of earthquake is obvious, and the advancements in this field are noticeable. However, I should note that when we are training our models using past records, historical models, and considering the climate change, we have different scenarios of climate change, but still predictions can be uncertain looking at longer spans of time. So the predictions come with some levels of uncertainty. Another use case, AI can be used to address humanitarian challenges. There are a lot of AI capabilities that could be used to benefit society. The United Nations Sustainable Development Goals, or SDGs, are the best known and most frequently cited societal challenges. And here's a graph that shows intersect of 17 goals and the use cases pointed out by McKinsey Global Institute analysis. As you can see here, the UN goals, you might notice a few of these UN goals overlap with AI use cases that I mentioned in previous slides, like affordable clean tech in a subclass of AI for Earth. And I think there's no strict boundary between AI for good applications and the use cases are the ones that defines the AI tools and capabilities that we should use for solving one specific problem. Last but not least, my favorite one is AI for accessibility. It focuses on addressing challenges to equality, inclusion, self-determination, such as reducing or eliminating biases. And let me give you one use case. Based on a work rooted from MIT Media Lab and Autism Glass, a research project initiated using AI, is that they wanted to automate the recognition of emotions and to provide social cues to help people with the autism, along the autism spectrum, interacting with the social environment. There are much more examples like this. And Microsoft is a pioneer in AI for accessibility. I should acknowledge that. They use AI tools to provide accessibility features for learning materials, language development, and assistive technology. Their mantra is building and advancing equity for people with disabilities. And there are a variety of outstanding projects led by Microsoft in vision, smart cities, and transportation and speech recognition. With this general intro, I would like to discuss about what we are working at in GeoMate. We provide accessibility maps and navigation tools for people with mobility disabilities. At GeoMate, we use artificial intelligence and machine vision technologies to analyze real-time safety and accessibility of cities. We are interested in finding barriers to find accessible routes for navigating people with mobility disabilities, which then encourage more sustainable forms of commuting locally. So we provide safer local travel for everyone traveling by foot or wheelchair, walker, and in general, ones who use assistive technology to move around. So how does GeoMate come into this discussion? So far, I've talked a lot about AI applications in general, but there are also more specific problems in daily life, right? For instance, the world has an aging population. and a large number of individuals with mobility disabilities. Currently, there are 1 billion individuals with some kind of disability, and this number accounts for 15% of the current population of the world. This number is going to increase according to the United Nations Departments of Disability, and the number will be 2.1 billion individuals living with disability by 2050. With a number as large as this, more needs and more efforts need to be done to ensure everyone has equal access to their local communities and to give opportunity to maximize their participation in society. And this is where our product, AccessMate, comes in. We have created a system to identify sidewalk issues and help residents travel within their community and even beyond city borders. So how does AccessMate work to improve urban life? Well, it provides a solution to inaccessible sidewalks. Our platform uses artificial intelligence in different ways using street imagery, high-resolution satellite images, LiDAR observations, and open source data to assess the health of sidewalk networks. We use deep learning for image recognition tasks and machine learning for mapping accessibility rate of sidewalk segments. But how does our data pipeline from data to deployment work? Well, for different models, the process is a little bit different. But in general, it looks something like this. We gather data, we unite the source of images or vector data set from various sources to develop the data set and creating a geospatial database. And then we pre-process the data, we verify and clean the data. And then we correct the incorrect target labels. This is done by our cartographers and prepare the data so that model can easily learn from it. And then we split the data into training sets and validation and testing. And this is done to evaluate the model's performance on unseen data. Then we train our model, feed the trained subset to the model to enable learning, and then we test and validate the model. We measure the model's performance on unseen data, and here we want to verify that if the model is learning the data and it's not just remembering it. Then we deploy the model, and for sure we iteratively perform all of these steps as the data grows and as our insight about the problem gets deeper. So first thing comes first, we need sidewalk information, right? Generally speaking, up-to-date sidewalk and road inventories are vital data sources for many operational and planning applications. Collecting manual data to create and update geospatial information for these inventories is very time-consuming and expensive. But using deep learning and advanced geospatial analysis, we can automate this process. And this is very first step of our operational process. We extract accurate and most up-to-date sidewalk network using high-res satellite images. Then, using street-level data, we extract objects in urban environment that can be potentially a barrier for a person with mobility disability. Here you can see examples of the objects detection and localization. And using our proprietary algorithm and architectures, there are different use cases for this platform, but for AccessMate, we use the identify possible obstacles for individuals with mobility disabilities. And we also identify curb ramps plus friction strips, which are significantly useful for navigating people with mobility disabilities and for identifying accessible routes. Then we map the accessibility ratio of sidewalks using another machine learning model by integrating different geospatial information, considering the criteria by standards such as accessibility for Ontarians with Disability Act. And we then map the accessibility to different levels of accessibility and we have a fuzzy approach. We can't say this is fully accessible segment or this is not accessible at all. So we rate the accessibility, and you can see the accessibility legend here. AccessMate can be used to help identify areas where sidewalks should be upgraded and updated to help prioritize these tasks. And we provide citywide analytics. The City Accessibility Information Dashboard provides an overview of different neighborhoods, different wards within the city. This information provides an easy way to identify areas that may require upgrades, and consequently to improve the lives of residents, particularly those with mobility disabilities. So this was only one use case of leveraging AI and location intelligence to make an impact in our society. So the other co-founder, our CEO and myself, we have had personal inspirations and domain experience and knowledge in this field. And that's why this is the main reason that we step into this particular field. And I hope as a member of Geo community, we can all make positive, continuous impacts in our society. So thank you so much for your time, and I would like to set the stage for a Q&A. This was a little bit shorter than it's supposed to be, I guess, but to get recent updates of GeoMate, please follow us on LinkedIn here there's a link to our LinkedIn and website, and that would be absolutely helpful to get connected and stay engaged. And I personally would be more than happy to connect later and share my thoughts and experience in this challenging journey of the use of tech and AI for good.
Thank you. Thanks, Nastaran. Hey, thanks a lot. So it seems like a very exciting project you're running now at the company. So I usually collect the question from audience through the chat box, but seems like I can manage it to ask people directly ask a question to you. So if anyone has questions from the audience, could you please raise your hands using the Zoom tool? Or either you can write down your question to me and then I can read. Okay, so right. So could you a little bit about your service now is you offering the services in the market, isn't it? Right? So who is your current clients? Is it governments or?
So our current clients are municipal folks. We have web app and mobile apps, and the users are people with mobility disabilities. This tool is free for all of the individuals with everyone, all of the citizens, and so they can have access to accessible parkings, accessible places, and we are going to launch our mobile app. It's in the beta version, and we are still fine-tuning the app, but then they can also use the navigation piece in the mobile app as well.
I see. So, right, I can, while I'm receiving the questions, I can continue to ask some questions on the technical side. And you mentioned about high resolution satellite image. That's the, what is resolution you're using now? It's, 30 centimeters or 50?
It's less than that. So depending on the data source that we have, it's something between 10 to 30 centimeters. But we also use the airborne observation. So we partner with municipalities, and the highest, the better, for sure.
I see. So is modality-wise, you only using airborne or the satellite in a top view? That is one modality, or you using ground vehicle or side view as well?
We use street view, street level images as well to identify the barriers, but we also look at the nadir view of the sidewalks to
Okay,
extract the sidewalk boundaries.
I see. So your AI networks is therefore, you have a one grand networks for consuming different modality, or your networks actually assign the different tasks for detecting different thing?
Yeah, we have different tasks for different
Ah,
things.
I
Yeah.
see. I
Yeah,
see.
we were thinking of ensemble approaches like you have, like you mentioned, with different modalities, but we believe that the performance will be better if we have one task, one specific task focused on one type of data.
Correct.
Yeah, right
Okay.
now we have different models for different tasks, machine learning models and object detection for using street level images or satellite nadir viewing observations.
Right. I guess it's slopes or the discontinuity, right? And in geometries, that ought to be critical for, just addressing the mobility issues, right? Like slopes, and so you're not using any three-dimensional information. You're only using 2D.
We actually use LiDAR observations as well. And yeah, so these are LiDAR observations that gives us a high density of the height changes because
Aha.
2 inches of height changes will cause problem. And according to AODA, this makes a route
Yes.
inaccessible if we have 2 inches of height changes. So we use airborne LiDAR as well. And
Right.
this is um, this is a great source of information for our models.
I see. So that laser from airborne and ground as well.
Yes, yeah.
Ah, I see. How many categories actually your AI managed to detect?
So this comes to the model that classify the objects. We identify the objects that might be a barrier for a person with mobility disability, and then we try to label those and identify those and localize those objects in the image coordinates and then transfer it into the latitude, longitude, and map it.
Sure. So
So
how many categories?
right now we have over 13 categories because at first we had less than that, but then we found that an object which can be a decorative feature of the urban area might be a barrier, right, for
I
a
see.
mobility disability. Then we had to have more and more classes.
Okay. So now I do with you offering accessibility sort of index, right? And regardless of types of disability, right? So
Not with honestly, we found it very challenging to have different types of disabilities managed in this task. We say this tool is appropriate for people with mobility disabilities, and we have a fuzzy approach of
sure.
finding the level of accessibility, as I mentioned, very low. If the segment has low accessibility to high accessibility rate,
Okay.
depending on the slope, the height changes, surface
Sure.
quality, all the criteria that AODA is telling us.
ADUA. So you're saying you set your primary clients is government. Seems like your service is more for decision makers and more urban planners, right? What about the services for disability people themselves?
So at each municipality, there are accessibility advisors and committees that they help the city have a better quality of sidewalks and increase the level of accessibility. They gather feedbacks from individuals, and so we try to reach out to them as well and get their feedback and understand what are the needs, what they want to see in the platform. And so that we have, and we are also partner with independent living centers in different cities to understand, to get feedback from the users as well.
I
This
see.
is really important. And the the main inspiration of this work was from the other co-founder, Amin, our CEO, who did his PhD in this field. He had multiple interviews with people with disabilities, and the insights and the inspiration came from that research. And so we have a chance to connect to the clients as well as the users, because the final user is people, right?
Okay, that's right. That's right. So I have one question from Andreas Beekman, and thank you for your presentation. Is there a possibility that the public can support this project? For example, do the AI model take user feedback into account? If yes, and how and which step? Only training or?
This is absolutely a great question. Thank you so much for pointing out this. Currently, we are not using crowdsourced information, and one challenge in using.
I think you muted it.
Okay.
Okay.
I'm unmuted. Yeah, thank you. So one challenge is using crowdsourced information is that we have to train our the people who want to contribute to know which thing is accessible, which thing is not accessible, how we define the classes and in accessible areas. And this takes a little bit of time, and it's not easy to incentivize people to contribute. But we are absolutely taking this into account, that the power of crowdsource is incredible. We have the feature of receiving feedbacks on the platform, on the web platform, and we have that feature in the app platform, so that, for example, someone is visiting a place or walking and found an inaccessible area, they can tag the location and saying that there's a problem here, and then we can investigate more by reading the feedback. But as you know, validation of the crowdsourced information is also challenging. But both, the question was about tagging the labeled images and contributing to the AI platform. And that piece is also in place, and we're thinking about it. But right now, we have our own staff who is doing the labeling.
Okay.
Third
It's
party.
more the augmenting the static environments and for active learning, right?
Yeah.
But what about the navigation itself? Like you don't need to collect all the behavioral, like a personal waypoint planning, and so maybe you can predict it, but maybe people do not actually following your predictive behavior planning, the mobility planning, based on the static environments. I don't know. So you don't have any plan.
So this is very interesting. Yes, we do have a plan for doing that, but as you know, because the types of mobility disabilities are very different, and we don't want to ask people to give us a profile of their capabilities, it's hard to interpret that if a person is not confident and not capable of going up the hill of slope of X, is that true for another person with
Yes.
another profile? So we don't want people to give us the profiles of their capabilities, and we want to have a generalized form of navigation.
Sure.
We look into the criteria
Yes.
of the sidewalk static information, like
Right.
as I mentioned, slope, aspect, height changes, and then we give the
Okay.
routes are accessible or inaccessible.
Okay. I know a few governments is actually using the public funds for creating pedestrian obstacle benchmark for AI, right? And do you have or know any community research or public community for collecting all those informations for AI?
Yeah, there is one research group called Sidewalk Projects. They have an incredible source of
Who are they?
yes, crowdsource. object detected by people, but their classes are, the number of classes and the categories are more general, and it's a little bit different from how we
Okay.
perceive the accessibility. So, unfortunately, we can't use their classes, and but they have initiated such project. I would say 3-4 years ago, a few
Who are
years.
they? Could you share that information?
Yeah, sidewalk projects.
Sidewalk project. Okay. Okay.
Yeah, and there are
Um,
so many other research projects in this area, mainly in US, and but the main barrier is that sometimes the research is great, and its significance is it's obvious, but we have to, if we want to map the city's accessibility faster and accelerate it,
okay.
we have to we have to generalize some of the barriers, and some of the technical barriers is that we look into models very specifically in research world, and to make it operational we have to make the models more easier to apply and deployable
Excuse
in
me.
scale, right?
Right. Um, okay. So the question to audience, and please feel free to. Okay. So now I have one question from Mohammed Javad in Bakili. How do you exactly gather training data for your object detection model? I mean, we might face various obstacles with different shapes in sidewalks, which may remain unforeseen. So, right, I think could you share, I think this is very time consuming, generating the reference data set for training your networks, right? And 13 categories, which most of them not available in publicly, I don't know. And so could you share your strategy for preparing the training data set?
That was a great question. Thank you so much. So it's interesting to know that in some cities we face with different barriers, and we can't really add another distinct class of, for example, some garbage in the middle of
Yeah.
the sidewalk, right? And it's sometimes misleading the model because we don't have a huge number of training set for that garbage. The shapes are different, so we we have a balanced approach. If we can name and define that class, and if we can have a good number of representatives in the classes, when we call it, we name it, and we define, and we try to add more labels by
Mm,
human data labelers. And how we increase our data set is that we run an inference, and we try to detect the objects, and after that a human labeler sits and verify and validate. And if they find a new object, we think about it. If this is a temporary thing, then we will miss it. If this is a constant problem, static barrier, then we absolutely add that to our class. And that is why we had 5 classes at the start, and then we turned into 13. But
mm,
it might get increased as we scale our product in different cities. Like, as I mentioned, in Toronto, we see a lot more different barriers compared to our region, Waterloo or Stratford, or
mhm,
it's like that.
mhm. So
We,
you're using the human labeler,
yes,
and
yeah,
I
yeah,
see.
absolutely. Yeah,
Uh,
we have our own web interface for labeling, and the verified objects goes into our own geodatabases,
I see.
and then we
Marky.
yeah, we retrain the model with the validated images and objects.
Right. So how could you say, I think the, to the interactive segmentations would be much easier than 3D. So 3D is really big headache. And how could you handle, taggings and training data set generations from 3D point cloud? And again, human labelers has a lots of resources for them to effectively label them.
So for tagging and identifying the sidewalk barriers, we look into 2D. We just
Oh, okay.
2D.
Right. Okay.
Yeah, we don't use LiDAR observations for
I
tagging.
I
It's
see. I
a
see.
lot of work, a lot of geoprocessing, and it's
Uh-huh.
very heavy. Yeah.
Makes sense. Makes sense. What about the available civil data set, like this factors provided by government? You're not using any georeferenced factor.
So to be honest, most I we can't rely on those because sometimes they're not up to date. But if
Uh-huh.
we have a partner, a client that we are working with them, and we know that the inspected data are up to date, and we can rely on that,
I
we
see.
incorporate those sources of
I
information.
see. I saw one of your slides showing the curve detections, and so these also automatically detected.
Yes, yeah, yeah, yeah,
Ah,
yeah. Yeah, we have to have curbs identified because when we are using the navigation piece, we should know
right.
that which
Sure.
segments are
Okay.
accessible,
So
right?
how many regions are you working with? Like at Waterloo only, or you how your data covers in quite many cities, or
Yeah, we have mapped 10,000 kilometers of sidewalks in Ontario, and
10,000
yeah,
kilometers?
so
Wow.
we hope to fully map Ontario next year. Yeah.
Oh, really? Okay. So, wow, that's very big data, I think. Right. It's great. Right. And so, any other questions from the audience? Costas? Okay. Right. So I think, just wait a second. Costas, you have a question? Oh, he's muted it. Okay. Right. Okay. So
I'm okay. Thank you, Gun. I'm okay. Thank you.
okay. So I think there's some questions related to your the Nestrans about your entrepreneurship. So I think you started your company in 2019 after PhD.
Yeah, I defended in March of 2019, but a few months just before.
So what is your biggest motivations and after getting the PhD to start startups? I think it is
So
decisions.
yeah, that was a big decision. To be honest, we have had this in our mind for a couple of years before founding the company, and the main inspiration was making a change, positive change. And to be honest, I love academia and entrepreneurship, and I'm still in both. I have both hats, and I'm in both boards. And so entrepreneurship is very different from research world. And my I would say safety zone was in staying in academia forever. But I dared to be an entrepreneur, and it feels amazing. We have our group, our team is 10 people right now, and this is really amazing. This is giving me inspiration to work and keep myself up to date. We have very smart young developers, which I should
I
take my
see. Right.
knowledge up to date and help them and supervise them, which is not far from academia world, right? The same thing but different roles. And yeah, the main inspiration was making a change. I have my dad was working not in this field, not in geo field, but he invented cars where it was hand control. So then someone came with a car and which was using pedals, and he turned it to hand control, and it was really inspiring me
Hmm.
that
Yeah.
People with mobility disabilities move around independently, and that was something that inspired me to.
Okay. So what is the biggest barrier so far as entrepreneurs? Um, and also your visions for the next few years, and where you want, what is your goal to achieve?
Yeah, so the goal is to map Ontario, map Canada, and having people using our mobile app for navigation. This,
Mhm.
if that happens, I would be really, satisfied. And
Right. Okay. In terms of business wise, is for how you're going to plan to growing it, and
so with partnerships and investments, and of course, growing our team, and more sustainable developments, and engaging our, bringing new customers and clients. Yeah, this
what
is,
you want to do.
yeah.
Okay. So before we're closing, I think could you say some, about your uh, comments and suggestions to geomatics field and students, and I guess you also have a geomatics people in your company, right? And so could you say something about
Yeah, absolutely. So this is an interdisciplinary field, and for me, I was talking to Mercedes. It's been 15 years that I'm in this field. It's intimidating for me to say that it's been 15 years of being. I'm not that old, but so for those of you who are considering entering this field, um, I would like to motivate you to investigate more, learning more about different journeys, different careers that you can take. It's not a fixed role. You're not um, you don't have to be a GIS analytics, remote sensing, developer. You can be an entrepreneur. You can work in other tech companies that needs geo knowledge. It's, so you're not bound to just geo
mhm,
community,
mhm.
and you can learn more about different peoples who has taken this career for a long time, like
Okay.
myself, and see yourself in 10 years, 15 years. Do you want to stay in this field, or do you want to even start this journey? And um, yeah, when I started this journey, I was like 18 years old. I did my bachelor in geomatics, and then I was fascinated by the capabilities and how interdisciplinary this field is.
It
And then
is.
I pursued my master, and then I went to a research institute, worked for a few years, and then I found myself, I want to be a researcher. Then I pursued my PhD in the same field in remote sensing, and then here I am. I stayed in this field for 15 years, and I'm really happy to standing like here.
Yeah, so the people who are, I don't know where they comes from, but likely to be who graduating from the university, who start the graduate programs, or who are in the graduate program. And I hope that the people will be contacting you
Yes,
to
absolutely.
discuss more about later on.
Looking.
Right. So yeah, so this is a great presentation. It's very, inspiring me, and I hope to other people's. I'm quite sure. So thanks for your times, and Dr. Nastaran Saberi, and all the best with your companies and adventures. Right. Um, right. Thanks for the people who attend the GeoTalk today. So the next speakers is invited 2 weeks after, when we're talking about the utility primitive representations in GIS, more digital twin, 2 weeks after. So I hope that many of you will continue to attend. See you later. Thanks, everyone.
Bye, everyone. Take care.